My next question is, when you have decided to go for clustering, what method of clustering would you choose? I mean, what is the rationale? One rationale or one method is you will do trial and error. Yes, that is the gold standard. You do a lot of trial and error. But is there any other way to identify whether should I go for hierarchical or should I go for non-hierarchical or should I go for, some kind of any other method? All right. Group-based method or whatever, all these things, on what basis do we take a call for the choice of the clustering algorithm?
Thank you, Nitin, for asking the question. Good evening, everyone. Good evening, Nitin. Yeah, clustering, very important topic. We did had a glance about this topic. When we talk about clustering, um, it is, as I mentioned, as a mandatory step, because ultimately, as part of the analysis, you are trying to identify some hidden patterns in the data. And clustering is able to help us get that information out because of the logic that we are applying here is to ensure that we get homogeneity, right? Group of records which are similar, homogeneous. So the question is, what technique should I apply for achieving this homogeneity? You apply any algorithm in the analytics or anywhere. Always the logic goes with the trade-off, right? Cost-based analysis have to be performed, and the trade-off is always between your performance that you seek, the application's performance that as a business you seek, and what is the accuracy that you seek. So it's basically a thin line between these two, and we try to balance them. And it's always going to be a subjective decision. Of course, that's how it is. Unfortunately, we don't have fixed rules. But there are certain pros and cons for each of the technique that we might want to choose. Practically looking at things, we always try to have the clusters arranged in such a way that the records are always disjoint. The clusters are always disjoint. But we do have overlapping clusters scenario also. But let me stick to disjoint clustering because practically that is what we do. Under this, we will have broadly two approaches again, hierarchical approach and non-hierarchical approach, like majority of you already know. And if you need explainability, if your clustering that you're performing needs to be explained, your business requirement says that, hey, whatever you're doing, you need to explain to your customers, then I would recommend you go for hierarchical clustering because it allows you to have a natural flow in your data, natural ordering in your data. And you also have this right visualization, we call them as dendrograms. So you can visualize it, and then you'll try to explain what pieces you are going to group your data into, how many groups you are going to split and all that. But the flip side is if you try to go with hierarchical clustering techniques, the drawback is that it cannot be applied for larger data sets. That's a very simple trade-off because you're naturally trying to arrange the data and you're trying to visually represent that. If you have large data, these two will take a hit. From a performance perspective, computationally, hierarchical clustering is very, very heavy. Hence, we look into the non-hierarchical approaches. And when we talk about hierarchical approaches and non-hierarchical approaches, there are many techniques that we can look at. The most popularly used technique in hierarchical is agglomerative technique. But we can also try and apply various other techniques within it. One of the thing is divisive clustering technique. It's exactly opposite to your agglomerative. And we also have something called as pure. We have chameleon. We have brick techniques. And when we talk about non-hierarchical clustering, we can apply again various techniques: k-medians, k-medioids, spam techniques. We can talk about non-conventional methods, fuzzy k-modes. This is for mode-related things. Then you basically have the density-based clustering techniques, which are DBSCAN, optics. For large data sets, we use meteoroids-based techniques. We have Clara, Clarance, we have Sting, we have Click, so on and so forth. Different techniques are available. But always we try to start with one, agglomerative clustering, two, k-means clustering. Standard practices is what you can say, or best practices is what you can say. But you always also have to do analysis between the performance of these models. Like Nitin rightly said, it's always trial and error. But as I mentioned, right, pros and cons. You'll have to look at these pros and cons and understand what is your business scenario and which model would be applicable in, or would be more suitable, I should say, on your business case, right? And again, trade-off, cost-based analysis, visualization, that is explainability, versus your performance, right? So this is basically about the clustering approaches that we generally take.
All right. Thank you, Sharath.